Guys, Mr. Bowman here. Today's learning objective is in yellow, and we are learning to explain the differences between theoretical and experimental probabilities. And on the left here, on the right here, I've got theoretical and experimental probabilities. And what we're going to do today is we're just going to discuss and contrast differing views between these two ideas. Talk about is the definition of theoretical probability, and that is the chance of an event occurring based on knowledge alone. And another way of saying that, this is thinking about the probabilities before an event has occurred. Contrasted with the definition of experimental probability, which is the chance of an event occurring, and that chance is calculated based on experiments or observation. And another way of saying it is you've actually got some kind of record, some kind of data to help you calculate that prediction. And to contrast theoretical probability, which was the probability you thought about with your knowledge before an event occurred, experimental probability is a probability calculated after an event has occurred. And in that case, the event might be an observation, perhaps an experiment, perhaps some recording of some data. Speaking of these theoretical and experimental probabilities, I've got an event or an example that I want to talk through. So the event we're looking at is throwing 10 coins to see how many tails that you get. If you think of the theoretical probability, your theoretical probability, you probably would have done an expected value calculation. You would have done the expected value would have been equal to n times p, which would have been 10 times 1/2, 10 coins, 1/2 being the probability of getting a tail. And from there, you would have concluded before the event happening that you're probably going to get 5 tails. And the really, really important part that I want to note here is that this here is an average. So if you did this experiment with 10 coins 100 times, you would expect to get an average that's really, really, really close to 5. So that's what you're expecting to happen without the event actually happening. Experimental probability relates to an action. So it's after event. So what I've actually done is I performed in an experiment, and you'll see that down below, and I've gone to a random online generator where I've flicked 10 random coins. And to find the probability with experimental data, so we're going to find the probability of tails. That there is going to be equal to, let's count up how many tails that we had. We had 1 over here, 2 over here, 3, 4, 5, and 6. So what happened here was we had 6 out of 10 happening, which was a probability of 0.6, or we had 6 tails just by counting them up. And you can see that there's a slight difference. 5, which is an average, and 6, which is recorded on experimental data. But as I said before, if we keep performing experiments, maybe we do it again, we'll get 5, maybe we do it again, we get 7, then we get 3, these here should average out to be close to our theoretical probability number. Kind of getting to the key part of this video. When you perform a theoretical probability calculation, there is no variation. Oops, spelled that wrong. So we've got no variation or randomness present. And that's a fairly unrealistic assumption or view, because in the real world, there is always going to be this idea of randomness. There's always going to be this idea of a little bit of variation from what you're going to expect. To illustrate that point in a bit more detail, if you do this experiment and if you do this theoretical probability and actually calculate getting 5 tails across our 10 coins, the probability of that is actually only 1 in 4, which means you are 3/4 of the time actually going to get something that you're not expecting to happen. So it'll be something that's not that 5. It could be 4, could be 6, could be 3, could be 7, Maybe more unlikely it could have been 2, could have been 8, but most of the time you're going to get what you're not expecting. The probability of not 5 tails, that was equal to 3 over 4, and that's way more likely to occur. And the piece of the puzzle that we are missing is in experimental probability, we are always going to have randomness, which is going to impact the outcomes that are going to come up. So it will impact outcomes. And we saw that in our fake coins tossing, we've got 6 tails and 4 heads. If we did that same experiment again, I actually did this a few other times, and then the next time I got 3 heads and 3 tails and 7 heads. And I remember one time I actually got 8 tails and 2 heads. So that randomness is a really, really important part, and that is not reflected in our theoretical probabilities. Final thing I want to emphasize in today's video is how we can use this idea of randomness to spot fake data. So I've got data 1 and data 2. So data number 1, data number 2. Before I reveal the answers, why don't you pause the video, perhaps in the comment section, maybe you can comment which one you think is real, which one you think is fake, just so we can see who thinks what. And then once you've written that comment, why don't you unpause and I'll get to my explanation. So spotting fake data, I normally rely on the idea of randomness. So if you think of some dice, the probability of the first dice landing on a number is 6 out of 6, so that's 1. And the probability of again rolling the same number is 1 out of 6. So that means the probability of getting a double across 2 rolls is actually 1 out of 6. So if you think of both of these here, we've got 12 dice, and the probability of rolling a double is 1 out of 6. So what that means is there should be doubles, there should be triples kind of in our data. And you can see that represented in data number 2. We can see triple 6, double 3, double 5. I'm expecting some of these doubles and potentially some triples to come up in real data because of the idea of randomness. However, if you look at example number 1, you'll see there's no doubles and there's no triples anywhere. And that's because this data here, this was the made up data, this here was fake. So when you're asked to produce fake data, often you'll try to think of the outcomes which you are expecting, and that is based on theoretical ideas. So here, when I made up this data, if you look at the first lot, well, I'm expecting 1, 2, 3, 4, 5, 6. I'm expecting them to come up kind of evenly and randomly. So instead of coming up with doubles and triples, I just rearranged 1 to 6 in a different order. And I then did the same for the bottom thing there. So no doubles, no triples. That suggests this data here does have that lack of randomness that we're talking about. So that there's more likely to be the fake data. Whereas the one down the bottom, it's got some doubles, got some triples. I'm expecting that element of randomness in my dice rolling. So a lot of big ideas in this video. Hopefully this gave you a good understanding of the difference between theoretical and experimental probabilities. Thanks so much for watching. Now let's get into heaps and heaps of practice.